In our previous lessons, we had begun looking at solubility of sparingly soluble salts. And I remember that we had looked at particularly the following. We looked at the solubility product, Ksp. We looked at expressions for Ksp for different electrolytes. We looked at equations for sparingly soluble salts. We looked at conditions under which Ksp is valid. We also looked at experimental determination of Ksp. Experimental determination of Ksp. Looked at that using the two methods. I said there are three methods, but we looked at two. There is direct titration, conductivity measurements, electrode potentials, but we looked at two, which are for our level. Then we went ahead and looked at introduced factors affecting solubility of sparingly soluble salts. Factors affecting solubility of sparingly soluble salts. So I also introduced those factors in our previous episodes. We said there are three factors that affect solubility of sparingly soluble salts. There are three factors. The first factor was common ion effect. That was the first factor, and I explained it in detail. The second factor was complex ion formation. And I hope that's where we ended with common ion effect as the factor in the previous lesson. And the third factor was that one, which involves addition. It's the opposite of this first factor here, the opposite of common ion effect, addition of a soluble compound containing no similar ion. Containing no similar ion as those of the sparingly soluble electrolyte. That is a summary of what we looked at in our previous episodes. Today, I want us to go ahead and look at very many examples that involve complex ion formation. And that is the major gist of this lesson that we are dealing with now. So we are saying, how does complex ion formation, effect of complex ion formation on solubility of sparingly soluble electrolytes? The first factor we looked at, which was common ion effect, we said common ion effect decreases solubility of sparingly soluble electrolytes. However, complex ion formation does the opposite. Complex ion formation increases solubility of the sparingly soluble electrolyte. So when they ask you the effect of adding an electrolyte that leads to complex ion formation, and they tell you to state the effect, you simply say solubility increases. Because such questions are common, state the effect of adding a salt that leads to formation of a complex ion. So there you say solubility increases. But if they say explain, then you have to go ahead and tell us what really happens and how does the effect of formation of a complex ion lead to increase in solubility. That's what I want to see with some examples here. In these examples, I'm going to see a few questions. And our first question is going to be this one. I will say silver sulfate is sparingly soluble. I think even if I didn't tell you that statement, you knew that. It's sparingly soluble in water. Explain what happens to solubility of silver sulfate when ammonia solution is added to its saturated solution. Silver sulfate is sparingly soluble. So what happens to its solubility when ammonia solution is added to its saturated solution? So since this question is an explanation, you have to write beyond your limits. You have to write beyond your limits such that we pick what we are interested in. Now, what does this first statement mean? Silver sulfate is sparingly soluble. This is what it means. Silver sulfate is this compound. Silver has valence 1, sulfate radical has valence 2. Is sparingly soluble implies that this is the equation for its solubility. That's the equation for its solubility. Now, explain what happens to the solubility of silver sulfate when ammonia solution is added to it. Ammonia solution doesn't have a common ion to silver sulfate. So here, common ion effect cannot be talked about. Common ion effect decreases solubility. Okay. Ammonia solution is also not an electrolyte. Okay, it's an electrolyte, but a very weak one. You cannot say it has an uncommon ion because it's not a salt. Actually, the best term to use is that it's not a salt. So here we are investigating what we are calling complex ion formation, which we have said it increases solubility. So what will you say? You will say solubility increases. That's what you'll mention about that. Solubility increases. What solubility increases? That of silver sulfate. Why? Go ahead to explain. Because silver ions these silver ions here form a complex, form a soluble complex with the ammonia solution. Did you know that? That silver ions form a complex with ammonia solution. I think I need to make it better. I have to say silver ions react with ammonia solution to form a soluble complex. Give us the name of that complex. The complex is called diamine. Amine is double M here. Silver 1 ion. Diamine silver 1 ion. Write the equation. So you have silver ions. They are reacting with ammonia to form the complex we are talking about, which is the diamine. Di means 2 amino ligands, silver 1 ion. That's the complex. We put a 2 here to balance the equation. After writing that equation, go ahead and tell us what does the formation of this complex lead to that will make the solubility increase. So because the silver ions which are coming from the solubility of the sparingly soluble salt are reacting with ammonia to form this complex, the concentration of silver ions decreases at equilibrium. Are we together?
Yes, teacher.
They say the concentration of silver ions decreases. Hence, so if it has decreased, silver sulfate will say, because you're taking, Mr. Ammonia, taking away my silver ions, I still have more within me. I'm going to replace them. Okay? So what happens is more silver sulfate dissolves. I don't expect you to say more silver sulfate ionizes. That's wrong. Don't say it ionizes or it dissociates. So more silver sulfate dissolves. Why does it dissolve? To restore the equilibrium which was there before silver ions were removed. To restore the equilibrium so that the equilibrium constant is maintained. To restore the equilibrium, maintaining the value of the equilibrium constant. Maintaining the value of the equilibrium constant. Are we together?
Yes, teacher.
So that's how we explain. How shall we award here? We shall say solubility increases. Why does it increase? Silver ions react with ammonia to form a soluble complex and its name, the equation. Concentration of silver ions decreases. More silver sulfate dissolves. Why? To restore equilibrium, maintaining the value of the equilibrium constant. Note that the same effect, the ammonia solution gives the same effect when added to which solution? When added to a saturated solution of copper 1 chloride. Copper 1 chloride is that kind of compound. It's also sparingly soluble. So in that case, the copper 1 ions in it react with the ammonia molecules to form the diamine copper 1 ion. So if they ask you the effect of adding ammonia solution to a sparingly soluble solution to a sparingly soluble electrolyte, which is in this case copper 1 chloride, as long as the solution is saturated, you'll have to say solubility increases and explain accordingly. I bring you another example. This time I'll say copper 2 iodate. Copper 2 iodate is also sparingly soluble. Copper 2 iodate has this kind of formula. It is a sparingly soluble electrolyte. In a solution, it gives us copper 2 ions and 2 iodate ions. Write the state here very well. Now, when you add ammonia solution to it, what happens? When you add ammonia solution to its saturated solution, the copper 2 ions react with the ammonia solution to form a complex. This complex, you looked at it in O level. Tetraamine copper 2 ions balanced by a 4 here. Okay? Yes. So that is our complex that we form here. So the same effect occurs if they ask you to explain what happens to solubility of copper 2 iodate when ammonia solution is added to it, solubility increases. Why does the solubility increase? It's because the copper 2 ions react with ammonia solution, form a soluble complex of tetraamine. This is one word. Tetraamine, amine double M, copper 2 ions, which decreases the concentration of copper 2 ions at equilibrium. Therefore, more copper 2 iodate dissolves. Why does more of it dissolve? To restore the equilibrium, maintaining the value of the equilibrium constant, hence increasing solubility. Are you getting me?
Yes, teacher.
So you should know the key points to write in case you're asked. Can you tell me any other ions with which ammonia forms a complex?
Zinc.
Zinc 2, zinc ions. So the same effect will occur with the zinc hydroxide. The same effect will occur with the nickel 2 hydroxide. Okay. The same effect will occur with sparingly soluble copper 2 hydroxide. The moment you add the ammonia solution to their saturated solution, the same effect occurs. And you should be able to explain the way we have explained previously here. You just replace the silver ions and the name of the complex with a complex formed in that special case. Are we together? Okay. Let me look at another concept here. Let me look at another concept. The question I have now says the solubility of lead 2 chloride decreases on addition of dilute hydrochloric acid. I think you are aware of that. Dilute hydrochloric acid with lead 2 ions or lead 2 chloride, solubility decreases in the hydrochloric acid, but increases on addition of concentrated hydrochloric acid. Actually, this can be lead 2 chloride, it can be lead 2 nitrate, it can even be lead 2 sulfate, it can be lead 2 iodide. It can either be a soluble salt of lead 2 or a sparingly insoluble one, a sparingly soluble one. So we are looking at the effect of addition of concentrated hydrochloric acid to a solution containing lead 2 ions. Why does it decrease when we add dilute hydrochloric acid? And why does it increase when we add the concentrated acid? Look at the concept here. Lead 2 chloride itself is sparingly soluble in water. Actually, we should say it's sparingly soluble in cold water, such that our equation is this kind of equation. We have lead 2 ions and 2 chloride ions. 2 chloride ions. So that's what we have. Now we are adding dilute hydrochloric acid Remember, dilute hydrochloric acid is a strong electrolyte. Are you aware of that?
Yes, teacher.
So it completely ionizes to give us hydrogen ions and chloride ions. What effect are you seeing here? I want you to think. What effect are you seeing there? Is it a common ion effect or complex ion formation?
Common ion effect.
This is common ion effect. Why common ion? We have chloride ions from the strong electrolyte and chloride ions from the sparingly soluble electrolyte. So that should be the basis of your explanation. Previously, you explained common ion effect. So the decrease in solubility when you add dilute hydrochloric acid to lead 2 chloride is due to common ion effect in this case. So what will you say? You will say lead 2 chloride is sparingly soluble in water. Write this equation. Then you say hydrochloric acid is a strong electrolyte. Dilute hydrochloric acid is a strong electrolyte, completely ionizing to give us hydrogen ions and chloride ions. Write this equation. This introduces chloride ions, which are common to chloride ions from the lead 2 chloride. The excess chloride ions are going to do what? The excess chloride ions react with lead 2 ions to precipitate insoluble lead 2 chloride. To precipitate lead 2 chloride. Are we together? To precipitate insoluble lead 2 chloride. So when the insoluble lead 2 chloride is precipitated, the reason of its precipitation is to do what? To restore equilibrium and to maintain the value of the equilibrium constant. So you say lead 2 chloride is sparingly soluble. Hydrochloric acid is a strong electrolyte, completely ionizing to give us many chloride ions. The excess chloride, the chloride ions are common to chloride ions from lead 2 chloride. Excess chloride ions react with lead 2 ions to precipitate lead 2 chloride to restore equilibrium, hence maintaining value of equilibrium constant. Are we together? So that's
Yes, teacher.
That's the first part as to why solubility decreases. However, why does solubility increase when you add concentrated hydrochloric acid? Why does solubility increase when you add concentrated hydrochloric acid? This is the reason. The lead 2 chloride reacts with chloride ions from the conc hydrochloric acid now to form a soluble complex. So this question has two effects in one. It has complex ion formation. It has common ion effect first, in the first case, and in the second case, it has complex ion formation. So in the first case, solubility is decreasing due to common ion effect. And in the second case, solubility is increasing due to complex ion formation. We shall have a 2 here to balance this equation. So who can tell me, what are you going to give as your explanation here? Why does solubility increase on addition of concentrated hydrochloric acid? I want one of you to give the explanation in that case. Muhammad, can you try? Yes, Muhammad. So what shall we say here? We shall say the presence of the high concentration of chloride ions from concentrated hydrochloric acid leads to the reaction between lead 2 chloride and the excess chloride ions to form a soluble complex of tetrachloroplumbate 2 ions. That's the name of this complex. Tetrachloroplumbate 2 ions. So that decreases the concentration of, actually, you may not go into that detail as we went into them in the first case. So here you simply say there is a high concentration of chloride ions from the concentrated hydrochloric acid. So the lead 2 chloride reacts with those chloride ions to form a soluble complex of tetrachloroplumbate 2 ions, which increases the solubility of lead 2 chloride in concentrated hydrochloric acid. I can modify this question and bring it in a graphical form. I can form a graph of this kind. I can say I have this kind of graph. On this graph, I have solubility of lead 2 nitrate. I have solubility of lead 2 nitrate here in grams per liter. That's on the y-axis. On the x-axis, I have concentration of hydrochloric acid added. And this concentration is in centimeters, moles per liter. Then I give you a graph of this kind. This graph is showing that solubility of lead 2 nitrate decreases when hydrochloric acid is still present in a lower concentration, because its concentration is increasing here. But when the concentration of hydrochloric acid increases, we find that the solubility of lead 2 nitrate is now increasing at high concentrations. The same explanation holds here. Okay? And here we shall not say that lead 2 nitrate is sparingly soluble, because this is a soluble salt. Lead 2 nitrate is a soluble electrolyte. But its solubility is decreasing with the low concentrations of hydrochloric acid. Why does that decrease? Why does the solubility decrease? Because this reaction is taking place with dilute nitric hydrochloric acid. There's a reaction between lead 2 nitrate and hydrochloric acid initially to form this precipitate. And what? And water. Is it water? No, it's nitric acid. And nitric acid. You can write an ionic equation as well between lead 2 ions and the chloride ions to form lead 2 chloride. So the reaction at first here is a reaction between lead 2 nitrate and the dilute hydrochloric acid to precipitate lead 2 chloride. That's why the solubility decreases. You have to say that the solubility of lead 2 nitrate decreases at low concentrations of hydrochloric acid, because lead 2 nitrate reacts with hydrochloric acid to form insoluble lead 2 chloride. The insoluble lead 2 chloride prevents any further attack by the acid to the lead 2 nitrate. Okay? And then solubility increases with increase in the concentration of hydrochloric acid, or at high concentrations of hydrochloric acid, because this reaction is now taking place. The lead 2 ions are reacting with the chloride ions now to form this complex. So here complex ion formation comes into play. So solubility later increases with increase in concentration of hydrochloric acid because the two ions react with the high concentration of chloride ions from the hydrochloric acid at high concentrations to form a soluble complex, give its name of tetrachloroplumbate 2 ions. Let me hope complex ion formation is understood and how it affects solubility of sparingly soluble compounds. Can I proceed to another factor?
Yes, teacher.
All right.